The 2026 Tesla Model 2 is finally beginning to show up in early cold weather testing, and what we're learning from these first trials is giving us the clearest picture yet of how Tesla's most affordable EV performs when temperatures drop. Today we're diving deep into everything you need to know about the Model 2's behavior in snow, ice, freezing wind, and extreme winter conditions. If you're thinking about buying Tesla's upcoming budget EV, or you're just curious how well this new compact car is shaping up, stick around because these first tests reveal some surprising results. Let's start with what the testers are noticing right away. Winter range. Anyone who has ever driven an EV in cold weather knows that battery efficiency drops when the temperature goes down. The question is, how much does the Model 2 lose compared to the Model 3 and Model Y? Early testing suggests that Tesla has taken steps to minimize winter loss, especially with an upgraded heat pump and a more efficient thermal management system. Test drivers reported that the Model 2 still maintains strong acceleration even at minus 15 degrees Celsius, and although range does drop, it is more stable than expected for a lower-cost EV. Some testers estimate around a 15 to 20% drop in extreme cold, which is actually better than several competitors in the same price category. Another major observation from first testing is the new battery chemistry. Tesla is rumored to use the next generation L, FP, or M3P battery packs for the Model 2, which are cheaper, safer, and more stable in cold conditions. In these early trials, the pack warmed up faster than older LFP batteries, meaning the car was ready to drive normally even after sitting overnight in freezing temperatures. Fast charging also performed better than many predicted, with testers reporting that the Model 2 quickly reached optimal temperature before charging, avoiding one of the most common issues with LFP batteries in winter. Now let's talk about traction and stability. The 2026 Model 2 is expected to come in both single-motor and dual-motor variants, and early cold weather tests show that the dual-motor version handles snowy roads extremely well. Thanks to Tesla's new traction control software, the Model 2 feels confident on icy corners, and even the single-motor version doesn't slip as easily as earlier compact EVs. Test footage shows quick torque adjustments that help maintain grip even when the road surface changes suddenly. This is especially important for buyers in Canada, Northern Europe, and colder parts of the US who rely on predictable winter performance. Heating comfort is another area Tesla focused on. Testers reported that the cabin warms up noticeably faster than the older Model 3 and that the heat pump runs quietly and efficiently. The new seat heaters and steering wheel heater activate quickly, and Tesla also appears to be testing an improved defrost mode that clears ice from the windshield faster, using smart airflow and preconditioning. This makes the Model 2 more convenient for early morning starts in freezing weather, and it helps save energy by managing cabin heating more intelligently. Cold weather region braking was also a highlight. Even in icy situations, the Model 2's regenerative braking system was smooth and predictable. Test drivers noticed that regen ramps up gradually, preventing the sudden braking force that can sometimes cause slipping on icy roads. When regen is limited due to temperature, the car automatically adjusts the feel so drivers still have consistent control. We also saw evidence of Tesla testing the new aerodynamic wheel covers designed for winter. These covers help maintain range by reducing drag while also preventing ice from building up inside the wheel wells. Combined with new winter tire options Tesla is expected to offer at launch, the Model 2's cold weather grip is shaping up to be far better than most compact EVs on the market. Now let's go into a key question buyers will have. How does the Model 2 handle charging in winter? Testers plug the car into both superchargers and home chargers at temperatures below freezing. Early results show that the improved heat pump plays a big role in battery preconditioning. The Model 2 reaches peak charging speeds faster than older Teslas, using LFP packs. Even after sitting outside all night, the car didn't struggle to heat the battery enough to accept a decent charge. This is a major improvement over many low-cost EVs, which can take 20 to 40 minutes before fast charging can begin properly in the cold. Another fascinating thing seen during testing is the effect of Tesla's new climate-smart software. When the car predicts cold weather overnight, it pre-cools or preheats the battery intelligently if connected to power. The Model 2 is expected to have a budget-friendly price, but Tesla still includes premium-level winter optimization features, making it stand out from other compact EVs in this class. Now, visually, the Model 2 prototype seen in cold weather tests appears to have modified underbody protection, likely to shield the battery pack from ice buildup, salt, and slush. This helps maintain long-term battery health and improves energy efficiency by preventing unnecessary drag created by snow sticking to the underside of the car. Testers also paid attention to interior performance. The touchscreen remained responsive in low temperatures, the cameras for autopilot stayed clear thanks to heated housings, and the car's self-driving sensors continued to function during snowfall. Even the door handles performed well, not freezing as easily as earlier Tesla designs, which had become a major complaint for winter drivers. Looking at all this data, what do these first tests tell us? The 2026 Tesla Model 2 seems to be shaping up as one of the most winter-capable compact electric vehicles ever made. Tesla clearly wants this car to be globally dominant, especially in colder regions where EV sales are growing fast. Everything from battery chemistry to traction control, from heating improvements to winter-ready software, shows that Tesla designed the Model 2 with cold weather users in mind. But the biggest takeaway is value. If Tesla really launches the Model 2 at its expected low price, while offering winter performance that competes with cars costing twice as much, this vehicle could become the best-selling EV worldwide. These first cold weather tests show that Tesla isn't cutting corners, even on its most affordable model yet. And as more prototypes hit different countries for additional winter trials, we will get even more data. But so far, the signs are incredibly promising. The 2026 Tesla Model 2 is proving that a low-cost EV can still deliver high-level performance, even when the temperature drops far below freezing. If you're excited about this new car or planning to switch to an EV in 2026, keep following these updates because the Model 2 might just be the game changer everyone has been waiting for. Another interesting detail coming out of these first cold weather trials is how the Model 2 manages battery recovery after long periods of freezing temperatures. Testers left the car parked overnight in conditions reaching nearly minus 25 degrees Celsius, and the next morning the Model 2's systems quickly began warming the battery pack in a controlled, energy-efficient way. Instead of dumping power into heating all at once, the car gradually heated different battery sections, allowing it to reach a drivable state faster while using less energy. This means early morning winter starts, something many EV owners struggle with, could be far less frustrating in the Model 2. Drivers reported that even after sitting outside in harsh weather all night, the car woke up quickly, the cabin heated up in just a few minutes, and the battery was ready for normal driving sooner than expected for an affordable EV. Another small but meaningful improvement seen in the testing is how the Model 2 handles ice buildup around the doors and windows. Tesla appears to have modified the door seals and window edges to resist freezing. Testers found that the doors opened more easily after being covered in snow and ice, a huge improvement for people living in colder regions. The window motors also seemed strong enough to break minor ice automatically, and the frameless glass didn't stick as badly as earlier Tesla models. These might seem like small details, but in real everyday winter use, they make a big difference in convenience and reliability. Overall, this additional round of observations reinforces the idea that Tesla designed the Model 2 with winter durability in mind. With improvements in heating, traction, charging, and winter startup behavior, the Model 2 is shaping up to be far more capable than anyone expected for a low-cost Tesla. As testing continues, we'll learn even more about how this compact EV performs in some of the toughest environments. But so far, these early results suggest that the Model 2 isn't just built for affordability, it's built for all-season performance.